In this lesson, we shall focus on COS 1501, Theoretical Computer Science. We shall be looking at past examination questions on this module. And we begin by looking at the first question. And good morning and welcome to the program. Right, we suppose that the universal set U contains the singleton set. So we have that a set that contains only one element is called a singleton. Right, so the universal set contains the singleton set with the element 1, the element 2, and the other elements and of course the set that has elements 1 and 2, and this is a universal set with the following subsets. So the set A is actually a subset of the universal set U. Similarly, B is also a subset. It is indeed a subset of what we call the universal set U. The set C is similarly, obviously, a subset as described as a subset of the universal set U. Answer questions 1.1 to 1.8 using the given sets by circling the alternative number you select. Question 1.1, which one of the following sets represents the union A union B? Right, so we understand therefore that in this case, rather A union C, right, so A union C contains 1A C union 2C, which means therefore A union C becomes the following, right? It actually therefore will contain each element that is in these sets. So it will contain the singleton set, or what we call our singleton. But moreover, it will contain the element A as well. And we also have the element 2 as well. It's going to be actually part of because we just simply select one element for each. Right, so 2 has been selected. In the same way, we select C as well. So we look for this set. And now this set is actually exactly the same as the set in option 3. And obviously one can say the order of the elements. This order of the elements is arbitrary, and therefore we have 2A and C like so. And in the end, what we're able to see then is that A union C is therefore option 3. So the correct answer is option 3. Option 3. Right, make sure that you understand what we've done, but also the methods that are involved in solving these particular problems. And this was the solution discussed of a past exam paper we randomly selected. There is a series of many past exam papers we shall discuss, of course. We move forward. Right, 1.2, question 1.2, which one of the following sets represents B intersection A? To do this question, we need to remember the following, that in particular, the set B was given the previous question, and the set B given the previous question contains the element 1, it contains 1, 2, B, and C as elements. And therefore we list those particular elements. Right, so we list the subset containing 1, also 1, 2 there, and the B together with the C. Okay, right, but also we actually recall what the set A was given as. In particular, it was given as the singleton set 1, or containing 1 and with A and C as elements of A, and therefore we state 1, A and C as elements of A. We continue to perform the set intersection, and therefore we actually list the elements in order 1, 2, B, and C. We find the intersection, and therefore you have 1, A, and C. We actually pause to reason and then say what elements are common in both sets. We can see, therefore, that the elements which are singletons are common in both sets. We shall list the first singleton there. Next, we actually are able to identify that C is also popular. It is a common element, and therefore we have exactly this. Now, the question is which option is the correct one here in this past exam paper. It is very clear that option 1 is the correct answer because it lists all the elements in B intersection A as required. And we've been, therefore, able to solve this particular problem in a step-by-step manner. And we proceed with our study of further questions. We attempt the next question. Right, question 1.3, which one of the following sets represent what we call the set difference? Right, so we compute the set difference. Right, so the set difference has a particular notations, but we shall discuss the set difference in detail there. So we can actually looking at the Venn diagram. But first, let us list the set C. We remember from the given information in this particular question paper that the set C contains elements 2 together with C, 2 and C. Right, 2 and C are members or elements of the set C, and we have the set B. Right, the set B contains the elements, right, 1, 1, 2, B, and C. We list those as well, right? So 1, 1, right? 1, 2, 1 and 2, B and C are members or certainly elements of the set B. The question, therefore, is which one is the correct answer in this case? So what we're going to do, we're going to compute the set difference. So we then say 2 together with C. Right, so 2 together with C. Obviously, we understand that they represent the elements there. Right, so if you have exactly that, we're going to say we have C minus B. Let's write it down. We write it down. C minus B. We have 2 together with C. We subtract B, which is 1, 1, 2, B, and C. And then we compute the set difference, right, which is obviously C minus B. And therefore, to do this particular set difference, we proceed as follows. Now, we think about the fact that from the set C, we remove the following elements. But this is also the same as, I want to make actually a clear explanation here. So if we have C minus B, it is C intersection B complement. So these things are the same. Right. So if these things are the same, therefore, one can be in a position to use this. So now that's what I'm going to use. So we can use C and 2 and C intersection, the complement of this set, which is the singleton 1, 2, C complement. What is C minus B? Right, what is C minus B? Right. Okay. C minus B, therefore, can be seen now. If we're looking at the complement of the set, we have to remember the universal set. Right, what is the universal set? The universal set contains 1. Okay, how do we know? We know the universal set contains 1, 2, 1, 2, A, B, and C. We list those. So it contains 1, 2, 1, 2, A, B, and C. So if we want to take the complement of this set, which is the complement of the set B. We're therefore going to have 2C intersection. The complement of this would be, we remove from this the singleton containing 1, 1, 2, and we also remove C. So in other words, we come to this set, we cross 1 out, we cross 1, 2 out, we cross C out, and we're left with the elements 2A and B. We list them. 2A, right? It's one way to do it, of course. 2A and B. And then now we're going to look out for what is common. And 2 is the only common element there. We can see very, very well. So we can see, therefore, that 2 is in the intersection. And therefore, the correct option is option 2 for us. And it is very clear, therefore, that we are able to understand and interpret this question very, very well. Let us move on to the next notion. Right, so now we're going to actually look at the sum of the two sets, A and C. So if we take note and remember that the set A itself contains 1 is a singleton, but also it contains the following. It contains A and C. We remember from the given information. C contains 2 and C. A plus C. Right, A plus C plus 2C. Okay, so when you add these particular sets, you're able to see, therefore, that what you're going to have to look very, very carefully, think extra carefully, and look at the following. So the sum of the two sets, A and C, is defined as follows. So we're going to select the element which is the singleton set, and we shall have as well, for example, the element 2 as well. We've selected the first here. We select also the first there. And we select also the element A, right? And now we actually do not select the element C because it is a common element. So we note that C itself here is common. By dint of it being common, right, being a common element in both sets, which is obviously found in the intersection of the two sets. Right, so it is a common element. And this common element, where do we find it? We find it in the intersection of the two sets. By dint of that, then we don't choose that one, and which means, therefore, we have 1, right? We have also 2, and we have exactly A as well. So we have 1, 2, and A. So 1, 2, and A gives us exactly the fourth option, and we have been able to compute the sum of two sets, A and C. And the sum of the two sets, A and C, is just short of the element in the intersection, the element C there. And now we continue to practice a little bit more. Let's just try the next question. 1.5 is the next question. Which of the following set represents A union C complement? Of course, to do this question, we need to remember what A is in the given information, but it contains the singleton containing 1 with A and C as well. But we note that C contains 2 and C as elements. By dint of this, we are interested in finding A union C. Right, the question then is A union C complement. What is this? But first, let us find the union. Perhaps that is the easiest way to do. The question, we can use what you call the De Morgan's law. Okay, but obviously De Morgan's law is used sometimes, and it is very applicable in this case. To solve this problem, let us find the union of the two sets. What is A union C? We list all the elements in the set A. We take the union with the set C, and now we are able to state the union A union C in detail, but also with all its interior elements. And now we are able to see that one occurs first. We can choose that one there, and next we can choose A, for example, and we can choose C, but we can also choose 2, and therefore this would be the union, because we have picked all the elements in A, but also all the elements in C, which are 2 and C. Okay, right, we're excited, but we pause and remember what we need to do here. So we need to actually think, but think extra carefully as we reason this out. But what then do we do in this case? We need to remember the universal set. The universal set. So recall, right? Recall the universal set. Recall that the universal set U contains the following. Right? It contains 1, 2. It contains 1, 2. It contains A, B, and C. And then right now, if we then are interested in finding A union C complement, which would therefore mean that from the A union C, you just get rid of the elements. So now let us come to the universal set. So we're gonna cross out the element there because we're interested in the complement. We're gonna cross out 2 for instance. We're gonna cross out A as well, right? And C, of course, A and C, of course. So we have 1, 2, 3, 4, and we crossed out the 4 elements, A and C, 1 and 2, and therefore this is the A union C complement. It contains only the element 1, 2, together with B as well. And it is very, very clear that the correct option here, as we practice more and more, and as we shall do a wide range of problems, this one contains 1, 2, and B, and it is clearly option 1, meaning therefore that the first option is the correct answer. You note that our discussion is recorded for control and quality purposes, and therefore would have a perfect chance to revisit this discussion in due course and make sure that we're able to interpret everything and be able to access information pertaining our discussion here even next time. Right, so we continue with 1.6. Which one of the following sets is not a partition of U? Right, so we are looking at the question 1.6. Right, the question 1.6. So now we need to remember that U is our universal set, but we're looking for a set that is not a partition of this. So we look at the fact that U contains 1, it contains 2, it contains 1 and 2, it contains A, B, and C, like so. And then now we actually, therefore, need to look very, very carefully and realize that in this case, which set would not be a partition, right? So you would realize, therefore, that the set here contains 1, 2, it contains 1 as well, 1, 2, 1, it contains BC, which BC does not appear here. So this set here cannot be a partition. The partition of U contains subsets of U. But we actually are rest assured that the subset BC is not there. Right, and so now you actually obviously note that because this BC is not a member of U. And so now it is something that you actually obviously need to think about. Right, and hence now we then say, if you look at this particular set, for instance, in 4, it contains the A, 2, BC, 1, and 1, 2 containing the subsets of U. And therefore, if we look at this very carefully, and also you look at the fact that this particular set here, does it contain, if you look at the union of all these, would it contain all the elements? Right. Would it contain, for instance, the element C? Would it contain the element B? Would it contain the element A as it is? Right. Would it contain the element 2 as well? So as a consequence, it is very clear, therefore, that the correct option here would be option 3. Right, so option 3 would therefore not be a partition of U. We're here to spend a lot of time discussing the notion of partitions of sets. So we shall spend a great deal of time discussing the notion of partitions of sets. We look at the next question. Let the set T contain A, C, and those particular elements be a relation. Okay, so these are some of the concepts we shall spend a great deal of time discussing. The notion of a relation. So now, if you then say we have this set T, and we're saying let this T be a relation on A, which one of the following statements is true regarding T? Right, so we need to check, of course, because number one, option 1, option 2, 3, and 4. 1 says T is reflexive but not transitive. T is symmetric and satisfies the trichotomy law or trichotomy. T is irreflexive and transitive. T is neither reflexive nor irreflexive. Okay. We are actually here and we want to discuss this particular question. Let us actually reason this very well. Now, to look at this, we are then saying let T be a relation on A. So you have T, but A contains the elements 1. We need to remember from the given information, what elements does A contain? It contains the singleton containing 1, and it contains A and C as well. And now we're asking the questions and we're going to answer them ourselves. Is it reflexive? Okay, but obviously because these are properties of a relation. Right, is it symmetric? Right, is it symmetric as well? So we check that. Okay, is it irreflexive? We check that. We check that. Right, so now let us see what this is the case. So now, if it is reflexive, every element must be related to itself. Let us check the singleton 1, 1. Is it related to itself? Right, so this singleton would have to be related to itself. So if this is a relation on A, would have to check if 1, 1 is there. Clearly, it is not there. This element is not in T, so it is not there. And this is our conclusion. It is not there in T. It's not there in T. Now, if you're dealing with A, C, let us look at A and see if we are able to see that if this is there. Right. So in terms of symmetric, but there is no CA. Okay. This means, obviously, I mean, what we're saying here in a nutshell, this means that our relation, right, so the relation is not reflexive. It's not reflexive. Okay, but also the relation is not symmetric. Okay, irreflexive. It is not symmetric because, of course, we can see a C, but there has to be CA also in T to actually allow us to conclude, therefore, that T itself is symmetric. And therefore, T is not a symmetric operation. Next, we're going to look at a reflexive property. Right, is CC present? Right, so you're going to be seeing that CC is present. Right, so we have that CC is present, and so the element CC is indeed present because we can see it in the relation T. And therefore, the correct option will have to be option 4. That says that T is neither reflexive, right? The correct option will have to be 4 to then say T is neither reflexive, because the number 1, it says it is reflexive, but surely it is not. The second one says it is symmetric, but surely it is not. The next one claims that it is irreflexive. So now the correct option will have to be that says it is neither reflexive nor irreflexive. Right. Obviously, see, as much as CC is present, but we would need more elements, and the correct option would have to be that T is neither reflexive nor irreflexive, right? Because we have seen that it is not indeed reflexive there, but it would not be irreflexive because of the fact that we do not have enough supply of elements there to make it irreflexive, despite the fact that C and C are present there. But obviously, we're yet to spend a great deal of time discussing these particular notions and solving a wide range of problems. Let us look at the next question. Question 1.8. What is the cardinality of the set? A plus C intersection B complement. Now, this set here, obviously look at the cardinality. The cardinality refers to the number of elements in the set. Number of elements in the set. Number of elements in the set. Right, number of elements in the set is called the cardinality. So when you have A plus C, right, let us check this out. So, but now to discuss the cardinality here, we need to remember what A is, we need to recall what A, B, and C were given us in the introduction of this question. So now we remember that they said A contains this singleton containing 1, it contains A, but also it contains C. Right, and you have this one contains 2, it contains C as well. We have B, which contains 1, but also it contains the following. It contains 1 and 2, but also it contains B and C, like so. The question then is, what then do we do with this? What then do we do with this? So what we then do here is to determine the following. Right, is to determine the set, because for us to find the cardinality of the set, we must be able to write out the set. But first, we remember we got A plus C. Right, so if we remember very, very well, we computed A plus C because A plus C was 1AC, right, plus C, which is 2C, and therefore we actually only removed C, which is the common element, and we were able to remember that this one was 1, right, it was also 2, and it was also A, like so. Okay, right, now with our analysis of this, we continue to look at things more. Right, so now we look at the intersection with the complement of B. What would the complement of B? Well, obviously we need to remember something interesting about the universal set. What is the universal set? The universal set contains 1, it contains 2, it contains 1 and 2, but also it contains A, B, and C, like so. Now, if we want the A union, we want the B complement. So let us find the B complement to be able to just find the intersection of this. And so what is B complement? So we go straight to the U, right? And looking at the U, we actually cross out the elements that are there. So want to find B complement, so 1 is common, so we remove it. And then also we have the what? We have the C, we remove it. We have the B, we remove it because it's there. We removed 1, we removed B, we removed C, we removed 1, 2. And then we have 2A. Okay, now let us ponder on this and reason this out. So that is the set. So if we have A plus C, right, if we have A plus C, but we're taking the union of this, right, and then we have B complement. What is A plus C? It contains 1, 2, and A. Intersection the complement, which is 2 and A. So we have the following. So now let us reason this out together and see exactly what we need to do here with this one. So the question then is, what is the intersection? Right, you can see 2 and A are both there, so we have 2 together with A. And therefore, we have 2 elements in this particular set. And now reasoning this very carefully, because we have been able to list all the elements in this set, it is very clear that the cardinality. So now we find the cardinality. So to find the cardinality, we write like as follows. So this is the cardinality, which is 2 and A, and the cardinality therefore is 2. The cardinality therefore is 2. The cardinality therefore is 2. The cardinality therefore is 2, because the elements are 2, and therefore the correct option is option 1. The correct option is option 1. Okay, right, we continue with more practice and we try the next question. Right, question 2.2 is very interesting, but it focuses on a survey. A survey involving 30 students is done to determine which study aids students prefer. Sometimes the students need to be aware of certain study aids for efficient academic execution of work, but also for adequate comprehension of what is being studied. And so what then happens is a survey is conducted to actually come to a conclusion and at least know what study aids are popular among students there. So now the following is found. Okay, 13 students prefer textbooks. Right, so we have 13 students prefer textbooks. Right, and so if this is the case, right, and we agree that 13 students prefer textbooks, 20 students prefer, so there are those who prefer textbooks, but there are 13 of those. 20 students prefer study guides, and then 17 students prefer online lessons. So it doesn't necessarily mean that the students prefer 1-8 only. So we note that. Doesn't mean they are in 1-8 only. But again, because this survey was involving 30 students, it means therefore the universal set contains 30 elements. Furthermore, 8 students prefer textbooks and online lessons. Okay, so we have those that are 8. 7 students prefer study guides and online lessons. 10 students prefer textbooks and study guides. Okay, this is what we've been given. Complete, this is what you need to do. Right, complete the Venn diagram. Complete the Venn diagram below with the given information and then answer the rest of the questions that follow. Okay, let us ponder on this particular question and reason these together. And we find the following answers here in a step-by-step fashion. And we have, right, so in look at 2.2, we have the following. Let us reason this out together and make sure we understand this very well, very well. So now, if you look at this particular question, we need to complete the Venn diagram. So let us put X in the middle. So for those students that prefer textbooks, study guides, online lessons, we put X for those. And then we reason that, right, if we then say 10 students prefer textbooks and study guides. Textbooks and study guides, it's 10. So here we're going to put 10 minus X. Because of the 10 minus X. So that 10 minus X plus X will give us exactly 10. Next, as we do the Venn diagram, we continue with our search. But now there are, for instance, 7 students prefer study guides and online lessons. Right, study guides and online lessons are 7. So here we would have 7 minus X also. And we have 8 students prefer textbooks and online lessons. Textbooks and online lessons, so those students are 8. So you have 8 minus X. Exactly that way. And therefore, now in the end, we actually obviously come to the conclusion that the textbook students, right, the textbook students are how many? So you note that there are 13 students who prefer textbooks, right? So in other words, if you look at the fact that there are 13 students who prefer textbooks, so you then say the textbooks, right? The textbooks would be 13 minus X minus 10 minus X. But also, right, so that is what we have. Right, and if this is the case, we then have the following. And then we would have to subtract also from the 13. Right, we said 13, we subtract X, we subtract 10 minus X, but we also subtract 8 minus X. And therefore, at this point, what answer do we get? So we get, therefore, that this is 13 minus X minus 10 plus X minus 8 plus X. So that T becomes the same as, what is this? We have 13 minus 10, which is exactly a 3. Right, a 3 minus 8 is a minus 5. And then we have X minus X plus X, which is 0. And this gives us exactly X like so. So now if we have exactly this, so we have X minus 5. Right, so we take note of this, X minus 5. But we're not done yet. We know very well that those students who prefer the study guides, okay, they love study guides a lot. And now those who love study guides, we're going to take note of those. Let us deal with those and compute those quickly. Right, so the study guides would be, for example, so there are how many? 20 study guides. So which means that we have 20 minus, right, so for the study guides, you have 20, then you have the study guides there. So you have minus X, we minus 7 plus X, we minus 10 plus X for the study guides. And therefore, what is the answer out of this? This is 20. Now, minus 7 minus 10 is minus 17. So 20 minus 17 is exactly a 3. Okay. So now we have minus X plus X, which gives us exactly X there. Okay. So this would be, the study guides would be 3 plus X. Okay. Let us continue with our analysis of the very interesting Venn diagram question. And now we look at the following. Let us look at the online classes. There's some students who love online classes relative to the study guides and everything else. Okay, but how many of those are there? Obviously, it is clear that those students are 17. So you're going to have 17 minus, right? We minus x. We minus this. So we minus 8, and then it's going to be plus 10. Plus x, excuse, we minus 7 plus x, and therefore it's going to be 17 minus 8 minus 7. So minus 8 minus 7 is going to be minus 15. 17 minus 15 becomes a 2. And we have minus x plus x is 0, which is exactly 2 plus x. Okay. So now this is exactly what we have. So now if we think about this very, very well, we have got this particular result here. So we're going to add every single bit of thing we have got. If then from t, right, which is 13, we subtract everything here, we have minus 5 plus x. For the s, we have actually 3 plus x when you remove all these things. And obviously, this one, for the online classes, we also have 2 plus x. Okay, so with this now, we need to add every single bit of thing. Right, so to add every, because you need to complete the Venn diagram below the given information and then answer the questions, the rest of the questions. Right, so if we have exactly done that, we actually have to complete the Venn diagram, but also we need to find our x in the Venn diagram. What is x in this particular question? And we proceed to find x as follows. Let us find the numerical value of x. So if we add every single bit of thing, we shall get what is in the universal set. And therefore, it means that if we look very carefully here, what we have is therefore that 30. 30, which is the number of the elements in the universe, is going to be exactly what? We start from the center of intersections. We begin with x, but also we're going to add the following 8 minus x. And then we add also the following 7 minus x. And then we add the following 10 minus x. And then we have the following plus minus 5 plus x. Right. 3 plus x. Plus 2 plus x. Okay. And so what is all this here? So what we're getting 30 equals, right? If we have x minus x is 0, minus x is minus 2x plus x is minus x plus x 0, leaving us with only x. We have 8 plus 7, which gives us a 15, a 25 with the 10, minus 5, it's 20. And then with the 3 and the 2 is actually exactly a 25. And then we're getting x is equal to 30 minus 25 is a 5. It's a 5. Okay, so now we're able to therefore see that x equals 5. X equals 5. So you can come here to the Venn diagram and actually obviously include the accurate numbers. For instance, we can see that x is equal to 5. And here we put 5 here. And if you put 5 there, you'd have, for instance, 0. Here you'd have 5. There you'd have 5 minus that, which is actually exactly what? A 3. And then here you have 3 plus 5, which is going to give us 8. And then a 7 minus 5 is a 2. And then we have 2 plus 5, which is 7. And therefore, these are actually the actual accurate elements of this particular Venn diagram. And then we will answer the questions that follow. Like the next question is very, very easy and straightforward. And here comes the question. How many students prefer to have textbooks, study guides, and online classes? 2 marks. Right. So obviously we're able to look and see. Right. Those are 5 of the students. So now those students are exactly 5 in number. Right. So now we are able to therefore see that 5 prefer all 3. Right. So 5 students. Right, 5 students prefer all 3. 5 students prefer all 3 because we have seen that 5 students are actually in the intersection of all the study aids. Okay, so we continue. How many students prefer to have textbooks only? 1 more. Textbooks only. Right, we have seen, therefore, if you look at this particular question here, right, so this one is the textbooks only, we've seen that textbooks only are minus 5 plus x. So, I mean, you're allowed to put this kind of detail and say it's minus 5 plus x, minus 5 plus 5, and therefore the sum is 0. And therefore the sum is 0. And therefore the sum is 0. Next question. Next question. How many students would like? Right, so you have exactly that. You have exactly that. Your 2, 3, 4. How many students would like to have study guides and online lessons, but no textbooks? There are those students who are going to like to have like study guides, online lessons, but no textbooks at all. The students are like, we don't love textbooks. We don't want them. What do we want? Study guides and online lessons. Let's check. So let's look at the Venn diagram. So obviously at this point, we analyze in this case that we would actually be looking at the study guides and online lessons, but no textbooks. Here are the study guides and online lessons, but no textbooks at all. And that would mean you have exactly 7 minus x. So study guides. Study guides and online lessons. Would be 7 minus x. X is 5. And the result obviously becomes exactly 2. Right. So which means that, and then we can say, hence 2 students. 2 students would like to have study guides, right? Study guides and online lessons. Study guides and online lessons, but no textbooks. But no textbooks, yeah? But no textbooks. But no textbooks. Right, but no textbooks, yeah? But no textbooks. So, yeah, it's something you need to note there. Let's look at the next question. But also would realize that in this particular case here, it is something we have done already. The 2 already. You could just take the 2. We'd have just taken the 2 and say 2 students prefer study guides and online lessons, but no textbooks at all. Next question. Okay, let us look at the following set theoretical proof without using Venn diagrams. That A intersection B complement union C is A minus B union A intersection C for all subsets A, B, and C of a vessel set U. Show all the steps. Show all the steps. Right. Show all the steps. Let us start. So to start this, you then say X is an element of this. You start with X that is an element of that, and you show that X is an element of this if and only if this is the case. So X that is an element of this would mean X is an element of A, and X is an element of B complement union C. This means X is an element of A, and X is an element of B complement. Right, X is an element of B complement, or X is an element of C, like so. And this would mean X is an element of A, X is not in B. Right, X is not in B, and you have X in C, X in A, and right. So at this point, if this is the case, this can be seen to mean X is an element of B, or X is an element of A. Okay, we're going to discuss this one, De Morgan's law. And X, an element of C. Right, let us put OR here. Let us maintain our, our OR by De Morgan's law. You can write like this. By De Morgan's law then means X is in A, and that or this is the case. So there's something called De Morgan. Right, De Morgan. De Morgan's law, which means that whenever you actually, or what you call this distribution, that is what I want to actually describe here, the set distribution property. So when you have A intersection B or C, it is A and B union A and C. Okay. So now, what is this? Right, so you have the following. So here take X not in B, still. Right, take X not in B, and therefore this would mean that X is an element of A without B. A without B, because AX is not in B. Or this would mean X an element of A intersection C. A minus B. You have this. Hence, okay, in the end, then obviously you would have proven this particular property. And so this is very clear that we have proven this particular property. In other words, we have shown that whenever X is an element of A intersection in brackets or in parentheses, B primed union C, B complement union C, it is exactly an element of the A minus B union A intersection C, and vice versa, because of the if and only if. The if and only if is also called a biconditional. It's also called a biconditional, and a biconditional obviously is an implication in both directions, in both the left and the right directions. So it is something that you need to take note of, and it is something that you need to understand very, very well. So it's very important, therefore, that you understand these particular set theoretic operations. These are set theoretic operations. These are set theoretic operations. And so, yeah, that is what we have. That is exactly what we have. Now, I'm watching the time. It's just actually a minute before 7. But now, take note of these things. There are tons of questions we shall be doing. But also the overall, but the entire syllabus for this module, we shall be solving a wide range of problems. It is so important that you get yourself actually attuned to this so that we can be in a position to make the most of our progress and be in a position to succeed. This is a very, very easy module where we can be rest assured that a distinction can be achieved with great ease and simplicity. Right, just watching the time is just exactly 7 a.m. And obviously our plan has been to run from 6 to 7, right? So I know there are tons of questions we shall do, right? But obviously we are concluding our discussion right now. And we shall, okay, this lesson is recorded for control and quality purposes. We shall send you the recording the next couple of minutes. So you will take, yes, right. We shall send the recording in the next couple of minutes, and we keep in touch. Then we'll talk more, and we'll follow the rest of the program diligently moving forward. Okay.
Thank you.
Thank you, dear. All the best. We'll talk then. All the best and God bless.
Okay.
Thank you.
Thank you. Bye bye.
Thanks. Goodbye. Thank you.